This session is on the base quantity temperature in the SI system. And remember, quantity deals with a number like 273 and a unit. And here we use a K. K stands for Kelvin. The Kelvin scale is the base unit in the international system. I could ask you who discovered the Kelvin scale, and you would say Thomson. Well, actually, Kelvin is the name given to Thomson in England from Queen Victoria when he was knighted because of his extraordinary science work. So it's Thomson, but it could be called Lord Kelvin. So the Kelvin scale. Now, how is the temperature scale actually put to use? And how's the instrument that we measure temperature, called a thermometer? And thermometer, basically you have a glass tube that doesn't expand or contract very much at all, and a very fine bored capillary tube when you pour a liquid that can expand and contract with adding or subtracting heat. And we can simply put a mark on this thermometer, and the mark put on it is when maybe you put it in an ice bath. We call it the ice point. And we then put it in boiling water, and we call it the boiling point. And then we can simply put any kind of marks we want in between there, and we have a scale that we can measure between freezing and boiling the water. Of course, you have to vary these scales, vary the liquid. The first liquid used was mercury, and also now we have a lot of them using ethyl alcohol, toluene, other kinds of organic liquids. And some of the new thermometers are electronic, uses solid state electronics and thermocouples. But we'll work with just a simple thermometer. The brief history: the thermometer started in the mid-1600s. It was very crude. It was really no scales. The first scale was the scale developed by a guy by the name of Fahrenheit. We use this in the United States yet, the Fahrenheit scale. In the Fahrenheit scale, the freezing point is 32 degrees Celsius, or Fahrenheit for water, and the boiling point is 212. About 20 years later, 1742, the scale was developed by a guy by the name of Celsius. It was called the centigrade scale for a long time, but it was changed back to honor Celsius. And a mere 100 years went by, and we have the scale now, the Thomson scale, we call Lord Kelvin scale. The Celsius scale went from 0 degrees for water, freezing point, to 100 degrees Celsius, a boiling point. Kelvin went from 273 Kelvin, no degree mark, just standard procedure, to 373, the boiling point. And notice the 100 degrees are the same. Now, if we look at the scale over here, we'll see that Celsius and Fahrenheit, differ in the degrees. For the degrees, if you have 9 degrees Fahrenheit, or equal to about 5 degrees Celsius, they are different, 9:5 ratio. But for Kelvin to Celsius, it's 1:1. So, in terms of conversions, which you have to do, if you have a temperature of, let's say 0 degrees Celsius, and you want to convert it to Kelvin. This is our conversions. 0 degrees Celsius, you just add 273 degrees, and that becomes 273 Kelvin. Add 273. Another example, let's say you're starting with minus 100 degrees Celsius. Add 273, and you come out with 173 Kelvin. If you add minus 273 degrees Celsius to 273, you come out with 0 Kelvin, and that's called absolute zero. And this is what the recognition of Kelvin using Charles's law on gases. We'll talk about that. He's the one that proposed a value called absolute zero, and all molecular motion, atomic motion should cease. The second one I want to do is sort of interesting, and this is a conversion from Celsius to Fahrenheit. And I like to use the add, subtract method. And it's add, subtract 40 degrees. Add 40, then subtract 40 degrees. And here's how we do it. If we have, you can see 100 degrees Celsius is 212 Fahrenheit, so I'll use this as an example. If you have 100 degrees Celsius and you want to convert it to Fahrenheit, first thing you do, step one, you add 40 degrees. This is 100 degrees Celsius. Add 40 degrees, and you get 140 degrees Celsius. Now the second thing you do is you convert it. You've gone to these, zeroed out the conversions here. I'm going to tell you what I just said. 140 degrees Celsius. And you multiply it by the fact that 5 Celsius degrees is 9 Fahrenheit degrees. And what you come out with is 252 degrees Fahrenheit. Now we subtract. See, the third thing, subtract 40. So 252 minus 40 is 212 degrees Fahrenheit. Now let me just show you what we had. We added 40, then we subtracted 40. The reason this method works is because Fahrenheit and Celsius, the scales cross each other only at minus 40 degrees Celsius. At minus 40 degrees Celsius, it equals exactly minus 40 degrees Fahrenheit. So initially when you add 40, you move up to a 0 point, and then you convert. See, this is step 1, that gets to a 0 point. Then step 2, you convert to whichever scale you want. Use 5 or 9 or 9 or 5. And then by subtracting 40, you bring it back. Okay, well, we're going to stop right there.